Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are continuing with the chapter. Okay, in the previous video we saw what is angle bisector theorem and perpendicular bisector theorem. Okay, so in this video we are going to study about properties of inequalities of sides and angles of a triangle. Okay, and its converse. Okay, and also we'll be solving questions based on this topic, this theorem, and also the theorem which we did in the previous video. Okay, so let's get started then. Let's see the first theorem. So this says that if two sides of a triangle are unequal, so if you take triangle xyz for example, okay, let's take, so this side, see, let's consider two sides, one xy and xz. They are unequal, their length, yes or no? Xz looks bigger compared to xy, yes or no? Therefore, then if they are unequal, then the angle opposite to the greater side. So let's say xz, okay, this side is greater compared to xy, okay. So if we say that, then the angle opposite to the greater side, okay, which one is the greater side? This. What is the angle opposite to this greater side? This angle, yes or no? So this angle is greater than the angle opposite to the smaller side. Which one is the smaller angle, smaller side? This side, correct? And the angle opposite to this side is this angle xzy. Therefore, what does this theorem say? The side which is greater and the angle opposite to the greater side, so which is this angle, is greater compared to the angle which is this angle opposite to the smaller side. Okay, so I hope you have understood. So what does this say? Greater side, greater angle, meaning greater side then opposite to the angle is greater angle. Smaller side then opposite to that is the smaller side compared to this greater angle. Okay, so I hope you have understood this. Let's see the theorem now, what it says. So what is given here for us is in triangle xyz, okay, what is given? Xz is greater than xy. Xz is greater than xy, correct? And what are we supposed to prove? That the side, sorry, the angle opposite to the greater side is greater. So we have to prove xy z. So this angle is greater than xzy, correct? So this is what we need to prove. So to prove, correct? So I hope you have understood this so far. Let's see it. So we'll do a construction now. Okay, so the construction, this says, okay, draw a segment, or let's say, okay, draw segment YP, okay, draw segment YP on, or you can say meeting XZ at P. So it is meeting XZ at P such that, okay, such that XY and XP, they both are same. Okay, so we are doing a construction here which gives you that this side, the smaller side, okay, of the triangle is same as this XP. Okay, so I hope you have understood. This is what our construction is. Now let's start with the proof. So the proof says, okay, so here first of all, if you see these two sides we have taken as congruent from construction. So can we say that this angle and this angle, they both are congruent also? Why? Isosceles triangle. Therefore let's write that. So xy is congruent to xp construction, correct? Therefore we can say xyp, angle xyp P is congruent to angle XPY. Why? Isosceles triangle. So we'll simply write that isosceles triangle theorem. Correct? So I hope you have understood this till here. Now, if you see angle XPY, okay, this angle XPY, okay, angle XPY isn't this angle an exterior angle of PYZ? If you think, let's say, okay, let's say this is Y, this is P, and this is Z. So the point X is over here. So if you see this angle, okay, this angle is an exterior angle for this triangle. Yes or no? So if you remember, if you don't remember exterior angle, go check out the video on exterior angle, okay, which has already been uploaded. So exterior angle, so angle XPY is an exterior angle of triangle PYZ, correct? Therefore, if this is an exterior angle, can we say that exterior angle is equal to sum of the remote interior angles? Yes or no? Therefore, we can say angle XPY is equal to PYZ. You know what is a remote interior angle? Because this is exterior angle. So there are three interior angles, 1, 2 and 3. Correct? But remote interior angle means far away. Interior angle but far away from the exterior angle. So this interior angle is close to this exterior angle. So this won't be taken. So this and this, they both are far away from this exterior angle. That's why the sum of PYZ, which is this angle, and PZY, which is this angle, plus PZY. Correct? So exterior angle is equal to sum of the remote interior angles. So you can write the reason, okay, that exterior angle is equal to sum of the remote interior angles. Or you can also directly say that exterior angle theorem. So it's up to you what you want to write. But if you see XPY, okay, this is equal to the sum of these two. So can we say that the exterior angle is greater than the interior angles individually? So I'll just take XPY, okay, because exterior angle is equal to sum of the two angles. There are two angles ka sum. So this exterior angle will be greater than this angle. Yes or no? If I say XPY, exterior angle is 100, then this will be 40. Let's say this is 40 and this is 60. So if you consider these two angles one at a time, the exterior angle will be greater than both of them one at a time. Yes or no? Therefore, we can say that XPY is greater than angle PZY. Yes or no? Because exterior angle is always greater than the interior angle. Any one of the interior angle, if you consider, okay, or you compare with the exterior angle is always greater. Okay. So if you are confused, go back and check the video for exterior angle theorem. Okay. Then after this, XPY. Okay. So if you see XPY is same as XYP. XPY is same as XYP. Therefore, we will write XPY as XYP. Let's name this as 2 and this as equation 1. So XYP greater than PZY from 1 and 2. Correct? So XYP is greater than PZY. Now, if this is greater, can I say angle XYP plus? Okay. So if I say I am greater than you, for example, if I take for this, okay, for proving this, if I am older than you, let's say my age is 21 and you are 18, okay, you are 18 years of age. If I add, okay, my age is greater than your age, correct? So if I add one more year to my age, like if I'm 21 for example, okay, though I'm not, but if I'm 21, if I add one more year to my age, I'll become 22, and you are still 18 or 17. So how many, the number of ages, if I add the number of years to my age, I'll be elder than you. Yes or no? That's why this is what it says. This, if xyp is greater than pzy, I add anything to this side will always be greater. Correct? So what I'll add here with xyp is pyz. So I'll add pyz. Correct? So just remember this example of age which I told you. Okay, so this will be greater than pzy. Okay, so if you see, xyp and pyz, so this is actually this angle. Okay, it is actually this angle plus this angle. See, xyp and pyz. So actually it is xyz. Therefore we'll write xyz is greater than pzy. Correct? So because these two addition is giving us xyz. Yes or no? That's why you write xyz as it's greater than pzy, or instead of pzy, we can also say xzy. Yes or no? Instead of pzy, we can say xzy, because same angle but different name. So we'll just say this xzy. Okay, so hence we have proved that the side, the greater side, this is the greater side, so the angle opposite to the greater side, which is xyz, is greater than the angle which is opposite to the smaller side. Okay, so I hope you have understood this theorem. Okay, now there is a converse on this which says that if two angles of a triangle, so here considering the side, we prove that the angles are greater or smaller. If the angle, the greater side, then the opposite angle is greater, and smaller side, then the smaller, this angle, opposite angle will be smaller. But here in this converse, it will be angle is greater, we have to prove that the side is greater. Okay, and if the angle is smaller, then we have to prove that this side is also smaller compared to the greater side. Okay, so that's what the statement says. Okay, let's see the statement. If two angles of a triangle are unequal, correct? So two angles are unequal, we are considering, then the side opposite to the greater angle is greater. So side opposite, so greater angle is, let's say, this. So this angle, side opposite to this angle is this side, correct? So this side is greater than the side which is this, opposite to smaller angle. Okay, so just the converse of this. Okay, so we won't be writing the proof for this, it's already given in your textbook, and I very well think that you will be able to understand the theorem on your own. Okay, it's easy to understand, which is given in the textbook itself. Okay, so we'll see some questions based on this theorem, and also the theorem on from the previous video which we did on perpendicular bisector and angle bisector theorem. Okay, so we'll see some questions. So let's see. So here are some questions. Let's take them one by one. So the first one, which says, okay, so this is the thing which is already given. So I've written in this format itself, given. Then what is to be proved? Okay, so what is given? In triangle ABC, segment AD and BE, okay, BE are the altitudes. So altitude means that from a vertex, if you draw an altitude, that means it is meeting the opposite side and making an angle of 90 degree. So altitude means making 90 degree. Okay, so if you remember, we had done median also. If you remember, what is a median? A median is if you have a triangle and if you take a midpoint of this side, and when you draw a line from the opposite vertex, then this line is called a median. Okay, so median is from a vertex to the opposite side but at the midpoint of the opposite side. Okay, So that's about median. So here we are discussing about this question. So this is given to us, and also AE. So this side and this side, they are also congruent, which is given to us. What is to be proved? BD, sorry, where is it? BD and BE. Where is it? AD and BE, sorry. This is AD. Okay. So we have to prove that AD is congruent to BE. So this plus this, we need to prove that it is congruent. Before starting, okay, let's name this point of intersection of the two altitudes. Let's name it as H. Okay, so let's name this as H. Now let's start with the proof. Okay, so here, okay, so what are we supposed to prove? That AD and BE should be congruent, right? So let's take these two triangles, okay, these two triangles, prove them to be congruent, okay, and then let's see what is to be done. So let's take triangle, okay, in triangle AHE and triangle BHD, correct? Now in AHE, angle AEH and angle BDH, they are congruent. Why? Because both are 90°. So we'll say each 90° given, correct? Because both of them are altitudes. So if they are altitude, that means they both are 90°, correct? So it is given to us. Now what else is given? AE is congruent to BD. So this is also given. So let's write that, correct? Now if you see, you remember vertically opposite angle. So we can say angle AHE is congruent to angle BHD. So AHE and BHD, so these two angles, correct? They are congruent by vertically opposite angle. Okay, so I hope you remember what is vertically opposite angle. Like if you have two lines crossing each other or they are intersecting at a point, then the opposite angles, that means if you consider this angle, the angle opposite to this is this. So these two angles are congruent. Or if you consider these two, then this angle and this angle, they are also congruent. Okay, so I hope you have understood this. So this is what we get. Therefore, by ASA test, we can say AHE congruent to BHD by ASA test, correct? Now, can we say AH is congruent to BH? Yes or no? I'll write it here, or let's write it here itself. AH is congruent to BH, correct? Why? Because CS, CD. Yes or no? Same way, can I say EH congruent to DH? EH congruent to DH. Same way, CS, CD. Yes or no? AH is congruent to BH and EH is congruent to DH. Yes or no? Correct. Now I'll just change this and I'll write DH, EH congruent to DH as DH congruent to EH. So I'll just write this as DH congruent to EH. So I can say, right, that if I say this hand is same as this hand, then I can say that this hand is same as this hand. Matlab, it means the same. Okay, you are just writing ulta. Yes or no? Therefore, name this as equation 1. Name this one as equation 2. Okay, now add these two. Okay, so add 1 and 2. Add 1 and 2. See, let's see what we get. AH plus DH. AH plus DH is equal to BH plus EH. Okay, EH plus BH or BH plus EH. So if you see AH plus DH, AH plus HD or DH, it is AD. So we can say this is AD. Yes or no? Because it is giving us AH plus HD or DH. So it is the whole which is AD, and also EH plus BH. So it is actually EB. So this is equal to EB or congruent. Correct? So we can write the reason for this, that AHD, AH and D betweenness, yes or no? Because H is in between A and D, and H is also in between B and E. Correct? So if you have forgotten this betweenness, you can again go check and check the chapter Basic Concepts in Geometry, okay, where we have done betweenness. So here I hope you have understood this. So we have proved that AD is congruent to BE or EB. Okay. So this was the first question. Let's see the next one. So this says that prove that if the bisector of angle BAC of triangle ABC. So let's draw a triangle ABC. Let's say this is ABC, correct? If the bisector of BAC, so BAC, so this angle, and we have to draw the bisector of this angle. So that means bisector. So actually bisector means what? That it divides. So if you are drawing a bisector for an angle, then it is an angle bisector. Yes or no? Therefore this will divide the angle into equal parts. So this and this angle, they both will be same. Correct? Therefore, what is given? If the bisector of angle BAC, so BAC, if the bisector of triangle ABC is perpendicular. So if it is perpendicular, meaning at this point it is making 90 degree to BC. Yes or no? Then we have to prove that triangle ABC is an isosceles triangle. I hope you have understood the question. There is a triangle given. You draw an angle bisector from A such that it is perpendicular to BC. That's the question given to us. Correct? We have to prove that triangle ABC is an isosceles triangle. So let's write what is given first. Okay. So what is given to us? Okay. So what is given here? Triangle and angle BAC. Let's name this as D. Okay. Let's name this as D. Angle BAC. Okay. Okay. Angle BAC. Sorry. AD is the bisector of angle BAC. Okay. So we are saying AD is the bisector of angle BAC. That means what? Angle BAD is congruent to angle CAD. Yes or no? Because if it is a bisector, okay, if it is a bisector, then the angles will be congruent. So we are writing it in given itself. And AD is perpendicular to BC. That is also given to us. Now what is to be proved? To prove ABC is an isosceles triangle. So triangle AB is an isosceles triangle. Okay. So here, now we have to prove that ABC is an isosceles triangle. That means what are we supposed to prove actually? We have to prove that this angle, okay, ABC and ACB should be congruent. So we'll just write that is to prove angle ABC is congruent to angle ACB. Yes or no? Or we can say if we prove AB congruent to AC, then also we can say that this is an isosceles triangle. So either prove these two angles congruent or prove AB and AC congruent. Any one. And if you are able to do that, then this is an isosceles triangle. So first we'll take these two triangles, we'll try to prove them congruent, and if we are able to prove these two triangles congruent by CSCT, we can say that this side and this side are congruent, or by CACT these two angles will also be congruent. If they are congruent, then this is an isosceles triangle. Okay, so let's see how we do proof. Okay, so we consider in triangle ABD and triangle ACD. Okay, so we are considering these two triangles. We can say what is given here, BAD. So we can write that quickly, whatever is given. So BAD is congruent to CAD, correct? This is given already. Yes. Now we can say ADB is congruent to ADC. Why are these two angles congruent, ADB and ADC? Because they both are 90 degree. If one angle is 90, then the other angle will also be 90. Yes or no? So we'll say each 90 degree, correct? Therefore, and AD is congruent to AD itself. Why? Because common side. Because AD is there in ABD also and ACD also. So in both the triangles, AD is there. So it is common side. So we'll say common side. Therefore, triangle ABD is congruent to triangle ACD by what test? ASA test. ASA test. Okay, so we have proved that these two triangles are congruent. Therefore, we can say, okay, angle ABC is congruent to angle AC. ABD is congruent to ACD. Why? CACT. Yes or no? Therefore, we can say AB, instead of D, we can say ABC. Why? Same angle but different name. Yes or no? So ABC is congruent to, same way, ACD, instead of ACD, we can say ACB. So ACB. Correct? So same angle with different name, you can write the reason. Same angle with different name, correct? So we have got these two angles congruent. Therefore, we can say triangle ABC is an isosceles triangle. Okay, we can write the reason by isosceles triangle theorem. Okay, so I hope you have understood these two questions. Now we'll take questions on properties of inequalities of angles and sides of a triangle. Okay, so let's see some questions based on that also. So here we are taking questions on inequalities. Okay, so the first question, it says that angle, so this is the triangle given. So let's draw it first. R, A, okay, J. Now R is 40, so let's say this is 40, A 70. So can we find J? So this is 70, this is 40. Therefore this angle will be, so we can say angle R plus angle A plus angle J equal to 180 degree. Why? You know the reason. Sum of the angles of a triangle is always supplementary. Therefore it is equal to this. So I want you to write the reason for it. Okay, then this is 40, A is 70 plus angle J equal to 180. Therefore, angle J plus 40 plus 70 is 110 equal to 180. Therefore, angle J is equal to 70 degree. Yes or no? Therefore, we get this also as 70 degree. Correct? Now, what are we supposed to find? Find the greatest side and the smallest side. So if you see, there are two angles which are same. So if the two angles, if they are same, okay, or let's take, this is 70, correct? Angle A is 70, therefore side opposite to 70. So if first of all, let's not consider A and J alone, let's consider them together. If the two angles are congruent, then these two sides are also congruent. Why? Because isosceles triangle. Isosceles triangle says if the angles are congruent, then the sides are also congruent. Yes or no? Therefore, these two sides are congruent. Okay. First of all, what are we supposed to find? Which one is the greatest and which one is the smallest side? Therefore, we can say this is 40, angle R is 40. Therefore, we can say AJ, okay, sorry. Here we can say angle R, okay, is smaller than angle A and angle J, correct? So angle R is both smaller than angle A or J, because A and J are the same. So we'll write just one of the angle, or let's write both of them, doesn't matter. So if R is less than A and J, therefore the side opposite to R is smaller compared to the other two. So we'll say AJ is smaller than RA and RG. Therefore, we'll say smallest side is AJ and biggest side is, we can say both of them, RA and RJ, both, because both are equal. So you can say RA and RJ. Okay, so I hope you have understood how to use the application for this of inequalities. So let's solve a question. Here one more question which says, okay, so this says this is the figure given to us, and we have, this is given PR and PQ, they are congruent, okay, and we have to prove that PS is greater than PQ, correct? So first thing which you should think about in this, what is given, I mean to prove, is if PS is to be proved that it is greater than PQ, that means we have to prove that this angle, correct, PQS should be greater than PSQ. Yes or no? Because side opposite to greater angle, angle opposite to greater side is greater. Yes or no? That's why we'll use that property and try to solve it. So let's see how we do it. Okay, so let's start with the proof. Okay, so here PQ is congruent to PR. Yes or no? Because it is given. So we'll write given, correct? Then we can say PQR is congruent to PRQ. Why is this? Because isosceles triangle. So this angle and this angle, they both are congruent. So isosceles triangle theorem. Okay. Now, if you see PRQ, this is Q, okay. If you see PRQ is an exterior angle, angle PRQ is an exterior angle, okay, of triangle PRS. So PRQ, so this angle is an exterior angle for PR and S, this triangle. Yes or no? Therefore, can we say angle P R Q? Okay, so as we did in the theorem itself, it said that the exterior angle is greater, okay, is greater than the interior angles. Yes or no? So we'll consider this interior angle and we'll say that this exterior angle is greater than this interior angle, sorry, PSR. So PSR. Getting? Because you already know that exterior angle is equal to the sum of the remote interior angles. So this angle PRQ is equal to this angle plus this angle. But since exterior angle is equal to sum of two angles, then if you consider both the two angles separately, means one by one, then that exterior angle will be greater than both of them. So PRQ is greater compared to RPS also. So it is greater than PSR, which is this angle, this interior angle, and this interior angle also. But we are not taking this. Okay. So here, we are not considering this for the proof. So here, PRQ is greater than PSR. But if you see, PRQ is same as PQR. Sorry. Correct? Therefore, we can say this, instead of PRQ, we can say PQR. Yes or no? So from 1, we can say this as 1 and this as 2. Okay? So from 1 and 2, we can say from 1 and 2, this is what we get. So if you see, PQR is greater than PSR. Now, can I write this as PQS instead of PQR instead of PQR? I'm writing PQS. So that, because same angle, yes or no? Same angle but different name. Same for this PSR, PSQ I can write. So angle PSQ. So we can say same angle, different name. Correct? So I hope you have understood this now. Therefore, we can say if this angle, okay, if this angle is greater than this angle, then we can say that the opposite side. So just consider this P, Q and S. Consider just this triangle. Ignore this PR. So if this angle is greater than this angle, which you see, PQS is greater than PSQ. Correct? Therefore, we can say that PS is greater than PQ. Why? Because this angle is greater. Therefore, the side opposite to greater angle is greater. Correct? And the side, which is this side, opposite to smaller angle is smaller. So we can say we can write the full statement. Okay? Side opposite to greater angle is greater, and side opposite to smaller angle is smaller. So you can complete the statement. Okay, so here we are able to prove that PS is greater than PQ. Okay, so I hope you have understood this question also. So this is it for this topic. Okay, in the next video we'll be continuing with the chapter. Okay, we'll be taking the topic similar triangles. Okay, so I hope you have understood this video on inequalities and questions based on them. Okay, so if you have understood, make sure that you share it with your friends. Okay, thank you for watching.